Yeah. Here I have written let us solve a problem, but you are going to solve the problem.
Okay.
Yeah. A very small problem of counting the words. The problem definition is there. Please read the problem definition there. If I give you a sentence like do as I say, not as I do. If I give you a sentence like this, your output should be the word and count. Like as, it comes two times in the sentence. Do, twice. I, twice. Not, only once. Say, only once. Have you understood the problem definition?
Yes. Yes.
Excellent. So what you will do?
Like when writing a program, what I will do?
Okay. Which language will you use? C language? Happily I can do it in C
Yeah.
language.
Yes.
Yeah. Happily I can do it in C language like hash include stdio.h, write a main, and inside that your logic please. Just give me the logic in some sentences, algorithm kind of thing.
Mm, like count the repetition of the words.
Okay. Yeah, the first word is do. You got do, right?
Yeah. So look
Okay.
for similar do, not considering the small case, uppercase. So look similar for the same word in the rest of the string. If it matches, increment the number. Take the next word. Look for the same word in the remaining string. If it
Okay.
matches, increase the count. Similarly,
Okay.
do at the end of the.
If I give a sentence here, only one sentence here, that is fine. If I give a complete book, suppose if I give a
Yeah.
complete book to you,
Hmm.
so how do you do that? Suppose the first word you encountered in the book, in the first page is do, let us say. So taking the do, will you search the entire book and check for do and update the count? Will you do that?
That will be a very long process.
Very long process. And what you will do? Throw some other idea?
Yes.
Think about. I have a
Um,
lot of time here. Think about this. We have a lot of time, of course. What you will do as a layman algorithm? Give me some layman algorithm. Any other thought other than this?
One thing that I can do is like
Yes.
what I have done a project in machine learning with R in which I have streamed the data from Twitter. So in R we have created a document term matrix in which what it has done, it has taken all the variety of words that was there in all of the tweets. So first it merges all the tweets and see for all the different words and then increase the count of each of the single words. So it created basically a matrix in which all the columns were made of all the different words that appeared in that document, and basically in the below row uh, it has written the count of each of the words.
Excellent. Excellent. If you use a kind of R kind of thing, suppose what if you use Java? Let me go
Mhm.
here. When the set of documents is small, a straightforward program will do the job. Let's write one here in the pseudocode. There is a small pseudocode here. Can you see the mouse pointer?
Yeah.
Yeah, this is a small pseudocode here. And a multiset. What is a multiset? You understand a multiset? A multiset is a set where each element also has a count. Kind of. A multiset will be like, multiset will have two columns. The first column is the word and the second column is the count.
Hmm.
So here is a multiset. Define word count as multiset. For each document in the document set, take one document. Tokenize. Have you seen the tokenize function in Java?
Yeah. Yes.
Yeah, tokenize. What the tokenize will do? The
Uh,
tokenize, yeah,
Break all the words
yeah,
from that.
break the words. So here, do as I do What is the word? I'll just go up, do as I say, not as I do. Multiset means do as it will divide, tokenize will divide like this. Am I correct?
Yep.
It will divide as this. And multiset means do, the count will come. Multiset is a data structure where the count will follow the word. Yeah. Multiset is a set where each element also has a count. It is a data structure. Data structure means if you say array is a data structure, right?
Yeah.
Array is a data structure. Multiset is also a data structure. In this data structure, each word will have a count. So do 1 as 1, I 1, say 1, not 1 as 1, I 1. In this way, we will prepare the multiset and display word count. Before displaying the word count is a multiset. The token plus plus what I am doing here, the token plus plus means whatever the word with the same here do is there any other do? No, as is there 2. It will make it 2. I, it will make it 2. Say, that's simple. Like that it will do.
Okay.
The simple program will do like this. Have you understood?
Yeah.
Yeah. So, this program, there are a set of documents. Each set of document will go as input to this program. The document, the complete document will be tokenized and then the word count of token plus plus is applied. A token means do is a token. Each word is a token. Whenever the word repeats, it will be plus plus means the count will increase. Multiset is a data structure which will have the word and the count of the words. So finally we will get the word and the number of times the word appeared. Simple program, right?
Yeah.
So this is a simple program. Why we need Hadoop? That kind of framework, blah blah blah, big hive and all those things. Simple program, yes, this program will work.
Yeah.
Simply if you write a Java program like this, if you give a set of documents, suppose 100 documents, that will work.
Time will increase if Java directly will process a lot of documents.
Yes, see the red color thing here? This program works fine until the set of documents you want to process become large. That is 100 documents, 1000 documents, fine, this program will work. What if you want to build a spam filter? That is a new word. What is a spam filter?
Like filter, like if I'm building a spam filter for emails, then it will look for those emails which have some like free words occurring most of the time. So it will classify that kind of mails as the spam mails. So if we apply spam filter, then for the new coming emails, it will classify those emails which have free words as the spam and those which doesn't have as the good email.
Excellent. You know everything about a spam filter. So to build a spam filter, you need to watch through millions of emails and there will be billions of words. So these words, these billions of words, if any of these words appears in those emails, millions of emails, you need to classify that email as a spam. A kind of, right? So
Mhm.
what if you want to build a spam filter to know the words frequency used millions of spam emails you have received? So the same logic, the above logic, this logic need to be applied to millions of emails. That means very large scale. What is the limitation here? See the limitation here. The limitation is looping through all the documents using a single computer will be extremely time consuming. Do you
Yes.
agree with the limitation?
Yes.
Yeah, you have one computer, may it be 5 gigahertz processor. Let it be 5 gigahertz processor and a lot of RAM I have given. 100 GB of RAM I have given. Let us say 100 GB
Hmm.
of RAM and I want you to process everything. Still, using a
Okay.
single computer, it will be extremely time consuming because it needs to process sequentially everything. So, what you will do to overcome this limitation? Tell me in your words what you will do with your knowledge.
I can parallelly build, like I can have 10 computers at the same time, and I will provide first 10 documents to one computer, other 10 documents to the other computer, so that they can process in parallel.
Okay. So, first all the documents you will put in one computer first, and there are 10 other computers. Suppose you have 100 documents, let us say, and 10
Yes.
computers. The first 10 documents you will give it to one computer, second 10 documents to second, third to third computer, and you will ask them to process.
Yes.
Am I correct?
Yes.
That is what my idea too. The solution need to distribute the work to several machines.
Yes.
The same solutions. So we are on the same page. Now we need to rewrite the program. Why we need to rewrite the program? The first 10 documents you have given it to one computer. In the first 10 documents, the word do appeared 10 times. In the second 10 documents, the word do appeared 2 times. Are you understanding? In the third 10 documents, word do appeared one time, only one time.
Yes.
So the final output when you are giving, you need to combine the 10 to 1,
Yes.
right? To
Yes.
say how many times do appeared, that means 10 to 1, 13 times you have to calculate. So you need to divide the program into two phases. The first phase will remain the same, and in the second phase you need to add what are all the outputs given by all the 10 computers.
Yes.
Do you agree with me?
Yes.
So phase 1, each machine will process the fraction of the documents here, and in phase 2 combine the results of all the machines.
Awesome.
So I will put 10 machines to do the phase 1 work, and I will put an extra machine. It will do the phase 2 work. All the 10 machines will send the results of its phase 1, their phase 1 to this machine, and in phase 2 I will combine all the things and output it to the user.
Yeah.
Will you do the same thing?
Yes.
Yeah, I will do the same thing. The limitation 2. Limitation 2, the first thing where all the documents are stored. In the previous example, what we are thinking, all the documents you will store with you. You will give 10 documents to machine 1, 10 documents to machine 2, like that.
Yeah.
So the storage of central server and the bandwidth are the bottlenecks. So suppose if there are 100 documents, you can store. Suppose if there are million documents, you cannot store in a single machine. And of course, you cannot distribute to all the machines. That is a
Yeah.
bandwidth problem. To distributing 10 documents to each machine, that will be a bandwidth problem. And storing million documents in your machine, suppose you keep on increasing the hard disk size. Let us say you are increasing the hard disk size to terabytes. The million documents are becoming billions. What you will do? That will be a bottleneck. Your machine will be a bottleneck. Am I correct?
Yes.
Okay. What is the solution? Solution is split up the docs among the set of processing machines. You do not give the documents, 10 documents to first machine, 10 documents to second machine. You will not give in this way. Whenever the document comes, you will directly say, machine 1 take this document, machine 2 take this document. So the storage will be on the permanently will be on the machines. A
Okay.
central server will not store and will not distribute the work, will not distribute the data. The data will be on the 10 machines, and whenever you say process and give me, they will process on their systems and they will give you the data. You will not transfer 10 documents to machine 1, machine 2, like that.
Okay.
Let us see limitation 3. Word counts, intermediate results are stored in memory until process 2 starts. So in the process 1, each computer works on the set of documents which the computer has and gives the results to process 2. Process 2 runs on a different machine, right?
Yes.
So until the process 1 machine transfers the data to process 2, the data need to be stored on memory of the system, the process
Yes.
1 system. It may exceed the RAM storage. Suppose there are 10 documents for each machine, RAM storage would be fine. Suppose if there are million documents for each machine, you are building a spam filter. Think about that now. Spam filter you are building. So a million documents for each machine. In the first million documents, the machine computed how many times the do appeared, how many times something appeared, like that. There will be so many words, 100 words let us say, a million words let us say. All the million words counts it have to store in the RAM storage until it transfers that to process 2, where the process 2 aggregates these things. Are you building the picture in the mind?
Yes, I'm building, but I'm little confused. Like, uh, if we are not storing the intermediate result, but intermediate results are generated by machines which are in the phase one. So those intermediate results should be stored in the memory of machine one of machines in the phase one.
Here we are for your questions. Okay.
Yes.
Yes.
Yeah,
Now,
phase one.
yeah, this is the phase 1 machine. This is the phase 2 machine. In the phase 1 machine, there are set of documents in the phase 1 machine. Applies phase 1 code here. Whatever the output it gets from these set of documents, it have to keep it in phase 1's memory until the time it transfers that to phase 2 machine.
Same. Yes, that's what I was saying.
Yes. Tell me your view.
Yeah, so the intermediate data, the process data from machines from phase one should be stored in the machines from phase one only. And when the data from all the machines are ready, they will directly send it to like, if I am done from my data
Hmm.
from phase one machine one, I will send it to A. Similarly, from 2 to B, 3 to C, something like that.
Yes. So you are saying that whenever you finish processing this, you will send it to A.
Yes,
Yeah, until the processing finishes, you have to store here, right? Until you finish with 1 million documents, you have to store somewhere here, right?
yes,
The phase 1 machine, this machine has allocated 1 million documents. After processing 1000 documents, it cannot send it to A. After processing all the documents that were allocated to this machine, then only it can send it to A. Am I correct?
yes, yes,
So for 1 million documents, it has to process all the words and its counts. So 1
yes,
million documents, a billion words and counts means the RAM size, it may not fit in the RAM size of this machine.
yes.
Yeah, that is the problem here. Exceed the RAM storage. For this
So we
problem,
are not storing the intermediate results anywhere.
intermediate results, explain your question once again.
The results generated by machines from phase 1 that are called as the intermediate results, right?
Yes,
So we are not going to store the intermediate results anywhere.
we are not going to store to permanent disk. We are not going to store. We are not going
Oh,
to
I
permanent
see,
disk.
I see, I see. So the raw data is in the permanent storage, the final data is in the permanent storage, but the intermediate data is not in the permanent storage.
Yeah, intermediate data is not in the permanent storage. As soon as you process all the million documents, you will get some data, right? That data you will send it to A, throw it to A. Until the time you process the million documents, you need to store everything, accumulate everything into the RAM. There, the RAM is a bottleneck.
Okay.